Welcome to this explainer. Today, we're taking something that usually feels like a massive, tedious chore, manual testing, and we're going to look at how to transform it into a highly automated factory using Azure DevOps pipelines. We'll be distilling the blueprints and breaking down exactly how you can set up a robust, scalable, and completely hands-free testing environment. But before we jump in, I want you to really think about this for a second. How much time does your team actually lose to manual testing every single week? Think about those mind-numbing repetitive clicks, sitting around waiting for builds to finish, the tedious documentation of results. It's exhausting, right? Now just imagine if a blueprint could run that entire process automatically in the background, while you and your team focus on actually building great features. That's exactly what we're going to unpack today. So let's dive into it. All right, here's our roadmap. Number 1. Core pipeline components explained. Number 2, Microsoft versus self-hosted agents. Number 3, decoding the YAML blueprint. And number 4, Docker and Kubernetes execution. Starting off with Section 1, Core pipeline components explained. Let's learn the essential terminology of our automated factory floor. Okay, so it all starts right here, the pipeline. Think of this as your master assembly line. It's the overarching entity that defines your entire workflow from start to finish. It governs your whole continuous integration and continuous deployment, or CI/CD process. Now, you can create these using a classic graphical editor, but honestly, more commonly today, they're defined using YAML files. And this is a massive game changer, because treating your pipeline as code means you can version control your infrastructure right alongside your actual application code. It completely eliminates that old, well, it works on my machine excuse, and protects your whole team from configuration drift. Inside that pipeline, Azure DevOps organizes work into a very strict hierarchy. It's kind of like a set of Russian nesting dolls. The biggest doll is the stage. That's a major logical grouping like your build phase, your test phase, or deploy phase. Inside a stage, you have jobs. A job is just a collection of steps that all run together on the same agent. Inside jobs, we have steps, which are your smallest unit of work. And finally, those steps are made up of tasks. Tasks are the highly specific individual actions, like, say, installing a .NET SDK or restoring a dependency.
Now, to make that hierarchy actually do something useful, the pipeline utilizes a few essential features. First up are artifacts. Basically, think of these as the physical boxes your factory produces, the files or packages created by the build process that get passed along to later stages. Then you have service connections. These are secure bridges that let your pipeline talk to the outside world, like a Docker registry. And finally, environments and approvals. This is where you set up review gates, to ensure there's crucial human oversight before any automated deployment actually goes live.
And before we wrap up this section, when you're handling data, it is absolutely crucial to distinguish between variables and secrets. Please don't mix these up. Variables are just reusable values you store to keep your code clean. You set them at the pipeline or stage level. Secrets, on the other hand, are a totally different ballgame. They are for sensitive data, passwords, API keys, database strings. They're stored securely within Azure DevOps and only accessed safely during the run. This keeps your credentials out of plain text logs and literally saves your team from a massive security nightmare. Moving right along to Section 2, Microsoft versus self-hosted agents. So we've got this beautiful blueprint defined, right? But a pipeline is really just a set of instructions. It's a recipe. So who or what actually reads the recipe, chops the vegetables, and cooks the meal? Who's running the code? The answer? Agents. You can just think of an agent as a virtual machine that executes your pipeline jobs. And right here is where you have your first major architectural choice to make. Microsoft-hosted agents or self-hosted agents? Microsoft-hosted agents are the ultimate plug-and-play. They're cloud-based, zero maintenance, and always up to date. Self-hosted agents, on the other hand, well, they require you to be the mechanic, but they give you total, absolute control to run on your own specialized on-premises hardware. If you decide to go with the Microsoft-hosted route, getting started is incredibly streamlined. You just create your pipeline, select your repo, and then pick the Microsoft-hosted agent pool and your OS image, say a Windows environment. From there, you just define your steps, set up your variables and secrets, and let it run. Microsoft handles literally all the underlying infrastructure. They provision the machine and throw it away when the job is done. You just sit back and monitor the progress right from the Azure portal. Conversely, setting up a self-hosted agent is definitely a bit more hands-on. First, you create an agent pool in Azure DevOps. Then, you actually have to download the agent software onto your local machine. You configure that software, authenticate it with a personal access token, and then run the agent as a local background service. Finally, you point your pipeline to that specific custom pool.
It's more work up front, for sure, but the payoff, it lets your automated tests run securely behind your own corporate firewall using your exact existing infrastructure.
All right, Section 3, decoding the YAML blueprint. Let's actually write the instructions for our pipeline.
So every YAML file establishes the rules of engagement right at the very top. Think of this as the setup phase. The trigger acts as a tripwire, meaning the exact moment new code hits the main branch, the pipeline springs into action. We tell it to grab a fresh Windows agent from the pool, build a release version, and we give it the exact coordinates for where to find the test projects and where to drop the final test results.
Once execution actually begins, the YAML moves fast. First, it checks out the source code so the agent has the actual files. Then it instantly configures the precise .NET 8.0 environment we asked for. Before it even tries to build, it reaches out to restore all necessary NuGet dependencies, just making absolutely sure there are no missing pieces. And finally, it executes the build command to compile the project. Now, once that code is built, the real magic of automated testing begins. The YAML commands the agent to execute the Selenium tests using NUnit in a headless mode. Headless just means it runs the browser entirely in the background without a graphical interface, which makes it unbelievably fast. It then takes those raw output files and publishes the test results directly back into Azure DevOps. Finally, it gathers up the rich visual extent reports and any failure screenshots and publishes them as pipeline artifacts. This is brilliant because it means human reviewers can easily see exactly what passed or failed without having to dig through confusing raw logs.
And finally, Section 4, Docker and Kubernetes execution. If you really want to supercharge this setup, you execute it using containers. With Kubernetes, your flow becomes almost like magic. Just look at this timeline. At second 01, Azure triggers the pipeline. By second 10, an entire testing ecosystem, a Selenium grid, spawns literally out of thin air inside your cluster. Test containers immediately spin up and begin running parallel sessions. By minute 5, your reports are beautifully generated and published by minute 6. But here is the absolute best part. At minute 07, the entire environment self-destructs. The pods vanish. You only use computing power exactly when you need it, and there is zero idle waste. It's incredible. By eliminating manual errors, standardizing your build processes with YAML, and leveraging those ephemeral containers, you aren't just saving a few hours, you are fundamentally changing how your team ships software. So I'll leave you with this thought. Instead of asking yourself what you have to test today, ask yourself, what is the very first manual bottleneck you are going to automate out of existence tomorrow? Thanks for joining me on this explainer, and we'll see you next time.